Section 4.5, Applications of Exponential and Logarithmic Functions. Part 1, Interest. The compound interest formula that we're going to use is if we deposit a certain amount into an account, how much will be there after T years. So we're not depositing anymore, we're not taking any money out, we just deposit a certain amount and leave it there. Then this formula would be the one that works. So the principal amount is P. We invest that into an account earning interest at an annual rate of R and change that to a decimal, compounded N times a year. Then the amount A in dollars in the account after T years is A equals P times 1 plus R over N, all raised to the NT power. So let's try this. Suppose $5,000 is invested. So $5,000, that's our principal amount, in an account earning 8%. So R would be 0.08 when we change that to a decimal. Compounded monthly, so N is 12, monthly is 12 times a year, and 5 years, so T is 5. So in the equation, I have A equals the principal, so 5,000 times 1 plus 0.08 over 12, all raised to the 12 times 5. Then I could put that in my calculator. You can put it in just like that if you use both sets of parentheses that I have written there. And we should get 74.49 and 23 cents. Always round to the nearest penny when we're talking about money. Makes sense to round to the nearest penny. Now, what if we do the same problem, but with continuously compounded interest? So continuously compounding means a set of 12 times a year, or every day, which would be 365 times a year, or every second, etc. We just compounded continuously. So that amount, the number of times a year we're compounding approaches infinity, would be one way to say that. Then this is the formula that we're going to use. So A equals P e to the RT. So we're going to do the same question. So A equals 5,000 times e to the 0.08 times t, which was 5. So 0.08 times 5. Put that in your calculator, and we get $7,459.12. So a little bit more than we got for compounded monthly. The more times a year the interest is compounded, the more interest that you're going to earn. How much would we need to set aside now to have $10,000 in 5 years if the money you set aside is invested at 8% compounded semi-annually? So our formula, again, I'm going to write this down, would be P times 1 plus R over N to the NT. So our A value is the 10,000. We want to have A in 5 years, so T is 5 years. And the interest rate is 0.08. And semi-annually means 2 times a year. So I have 10,000 equals P times 1 plus 0.08 over 2, all raised to the 2 times 5. Okay, so now to solve for P, I need to divide both sides of the equation by the 1 plus 0.08 over 2 to the 2 times 5. So I have 10,000 over 1 plus 0.08 over 2, all raised to the 10th power. 2 times 5 is 10, which was P. Put that in your calculator, and you should get 6755.64. So $6,755.64 now, so that at the end of 5 years, you would have $10,000. How long will it take $6,500 to double when invested at an annual interest rate of 17% compounded continuously? So the continuous compounding formula, A equals P e to the RT. I want to take 6,500, double that. So double 6,500 would be 13,000. So A is 13,000 equals 6,500 times e to the 0.17 t. So t is what we don't know. To solve this equation, I'll first divide by 6,500. 13,000 divided by 6,500 is 2, equals e to the 0.17 t. Change this to logarithmic form, and I get the natural log of 2 equals 0.17 t. Divide by both sides by 0.17, and I get the natural log of 2 divided by 0.17 equals t, which is approximately 4.08 years. So it would take about 4 years, a little bit more than 4 years, to double the money if we start with a 17% interest rate. Now that's a very high interest rate, probably a very high risk investment, But if we do get 17%, then this is how long it would take. Notice that it doesn't matter how much we started with. Whatever we started with and ended with is double. We want it to double. So if I divide both sides by the 6,500, I do get 2. So when I want to double something, the equation would look like 2 equals e to the RT. And we don't have to worry about that p. We start with $1 and with $2 would be one way to think about it. It doesn't matter how much you start with. It's going to double in the same amount of time.